Okay, we're going to look at linear equations and graphs on this video. So, graphs of a straight line. The gradient formula is y2 minus y1 over x2 minus x1. Please do not forget that. You'll be using that all throughout methods. So, calculate the gradient of a given line. Firstly, label your x1 and y1, and then x2 and y2. In terms of which ones you do it, it doesn't actually matter. You can swap the ones for the twos, but they must both have the same they must both be from the same point, because those little numbers there actually mean they're from the first point and the second point. So if you had x1, y2, that does not work. Sorry, there is something funny going on with my pen, as you might have noticed in the previous few videos. Yeah, there we go. Alright, so m equals to y2, which is 0, minus y1, which is a 4, x2, which is 10, minus x1, which is a 0. So we have negative 4 over 10, which is a negative 2/5. Alright, now, here comes a new part. Sketching half planes. What half planes are regions in which you have an inequality. So, if y is greater than the line, then that means it's above the line. So you might notice there's a straight line sketched here, but then it's put up above it. If it's below the line like this one, then you just sketch it underneath the line. Pretty straightforward, idea-wise. Okay, sketch the points for which these things occur. So, A, we have y equals to negative 3 over 2x. The gradient is negative, so simply sketch a negative graph. There is no y-intercept, thus the y-intercept is 0. And then if you want to show that this is negative 3 over 2, if you substitute 1 in, you get negative 3 over 2. B. So we want 2x minus y equals to 6. So if we solve for x-intercept and y-intercepts, x-intercept is x equals to 3, and then y-intercept is y equals to negative 6. So we'll put that in. So we want x equals to 3, y equals to negative 6. It's a straight line that goes that way. Sorry, use a ruler. I don't have a ruler here, unfortunately. And then, if we want 2x minus y less than 6, we need to rearrange that. So we have negative y is less than 6 minus 2x. Therefore y is greater than 2x minus 6. That means we want y above the line. So when we're sketching that region, we have the same points. However, you might notice this one is not equal to, so this straight line doesn't work. We need dotted lines. Again, please use a ruler, do not do what I'm doing. And then we simply color in the region. This is above the region because it's greater, like so. You can color it in fully if you like. Alright, see, x equals to 4, for x to be equal to 4, it covers the section where x is equal to 4 the whole way. There's a straight line going that way. And then D, y is greater than or equal to negative 2. So look for negative 2 on y, right there. And it's less than or equal to, so that means it's a solid line. Then it's above the region because it says less than or greater than or equal to, so simply color that bit in. Alright, we're going to look at how we put all of this in the CAS. It's just the same examples as I put down before. Now, if it's got an equal sign, we can just leave it as it is. So if you're wondering, graph and table, and then I'm in this menu. Now, on the top here, you can actually change what type of graphs you want if it's rearranged in a certain way. You might notice the only one that it doesn't have is if you have the x and y on one side. There are ways to counter that, and I will come back to that in a bit, well, at some other point. So, y equals to negative 3x over 2. Let's just put negative 3x divided by 2. Pretty simple. Press it, and it'll graph it for you. So part B, you have 2x minus y equals to 6. If you're on the main menu, and this is where I was saying if you have it all on one side, it won't graph it for you normally. You have to put it in here in the main menu, press the graph, highlight it and drag it in, and try that again, and it'll graph it for you. Now, if you want the region that it's given, I don't think this menu does it for you. We'll try it anyway, see what happens. Oops. No, it doesn't work. So, because it doesn't work, we'll have to do some rearranging first. Now, best way to do it is to have it so that y is equal to the rest. So what we'll do, use the solve function, so action, event solve. You might notice you can do the same thing in interactive, but you can't copy it. We've already typed it in, so I want to be able to copy it, so I'm going to use action. Now we want this in terms of y. So then y is greater than 2x minus 6. So if I'm correct, you should be able to copy it. Good. Go on menu, graph and table, then simply, no, you cannot do that. Okay. Anyway, it's 2x. Y is greater than 2x minus 6. So use the y greater than symbol. This will then change whatever we type in into a greater symbol, and your calculator will actually color in the region for you. You might also notice they actually use a dotted line to show you where whether or not it's greater than, strictly greater than, or greater than or equal to. Alright, once you've done that, we want x equals to 4. It's the same thing, change it here, x equals to 4. Graph it. You won't see it because x equals to 4 is there. Then y is greater than or equal to negative 2. It's the same thing. There you go. Alright, forming equations of straight lines. So we can use the formula that's written there. Some of you should have seen this in Year 10. What you need to do is you need to have the gradient, and then you just substitute a point in. So, part A, form the equation with the line with gradient of 4 passing through the point 3, negative 7. So we'll substitute that in. Y minus the y value for it is negative 7 equals to m, our gradient is 4, x minus, and then the point is 3. So we have 4x minus 12, and this is y plus 7. Move that over, and we get y equals to 4x minus 19. Okay, part B. Form the equation of a line passing through the points 5, 9, and 12, 0. So to do that, find our gradient first. So y2 minus y1, x2 minus x1. So we have negative 9 over 7. Then substitute all of this into the formula. Pick one of the points, not both. I'm going to pick the 12, 0 point because then it's y minus 0 and it's nice and easy to work with. And then simply expand it. What is that? 108%. If you want to, you can actually move values over, but I'm just going to leave it as that. Okay, part C. The line shown determine its equation. So we have a y-intercept of negative 4. So that's 0, negative 4. And then our gradient is, it has a rise of 4 and then a run of 8, so it's a half. So then our equation is going to be y equals to half x minus 4. Okay, D. Obtain the gradient and the coordinates of the y-intercept with the equation 3x minus 8y equals plus 5 equals 0. Simply rearrange that, solve for y. So we have negative 8y equals to negative 3x minus 5, moving all the rest of them over. Then we just divide the negatives, so all of these become positive. So we have 3 over 8x minus 5 over 8. Reading off that, our gradient is equal to 3 over 8. Our y-intercept is negative 5 over 8. Just a note, I was going to say at the start of this video, we also have y equals mx plus c. So just remember that's the y-intercept. And that's the gradient. I'll just briefly fix this up so you can see what's going on.